Hello, this is your database coach, specializing in all things Couchbase. In this module, we're going to take a look at how to diagnose a slow-running query using the query plan. This is a key skill you need to develop in order to determine what the cause is behind any slow-running query. One of the key activities necessary in diagnosing a slow query is to run it against a dataset that is a match for what the query will run against in a production situation. Now, this may be in the production cluster, or a clone of it, or it could be a QA cluster that has a smaller dataset, but is still a reasonable subset of the data patterns that will be found in the production cluster. The reason for this is that we want to reproduce as accurately as possible the conditions that will be found in production. In a development cluster, even if the dataset is a reasonable facsimile of the production data set, odds are it won't contain enough data to identify the problems. Sure, if you've got a very inefficient index, it might bring that out. But odds are that even the most inefficient query will still perform well enough to mask any problems. That's why it's important to actually run the query against a sufficiently large data set that is close enough to what will be in production to expose the shortcomings. And if you have the opportunity to run it on the production cluster, it has the potential to expose a couple of issues that you won't identify on non-production clusters. Issues like if your cluster nodes might be undersized and overloaded. If it's a non-production cluster, I can just about guarantee that the nodes are undersized and overloaded. I would be surprised if they weren't. But if your production nodes are undersized and overloaded, that's a guarantee that you'll have performance issues, no matter how well-tuned your queries are. So let's break down the steps to diagnose a query performance and determine what the problem might be. First, we run the query, returning actual data. Once the results have been returned, we click on the Plan or Plan Text buttons above and to the right of the results window. And we start by looking at which phase is taking the majority of the time, and for phases where there is a large difference between the in count and the out count. Unless this phase is a grouping phase, a large difference between the in and out counts indicate that the index scans are not sufficiently selective, and our query is fetching more data from the data service than we really need. This tells us that we need to make sure that we have all the filter criteria included in our index, with no skip data elements in the index. This should improve the query performance just by reducing the number of documents being fetched. But what if that's not the problem we need to solve? So the next thing I look at are the phase timings. Which phase is taking the most time? If you're looking at the query plan from an actual run of the query, each phase will have timing information. You can quickly look at these to see where the most time is being taken. Then, if you drill into the phase detail, you should see detailed timings. In particular, you should see times for 2 or 3 types of timings. Exec time is the time that the query engine spent processing this phase. If this value is high, you probably need to significantly redesign your query to simplify what's being done in this phase. Serve time is the time spent waiting on another service. You typically only see this in the phases where the query engine is waiting on either the index service or the data service. Although if you are calling the scan function or using an FTS flex index, this could also be waiting on the FTS service. If the serve time is high, what you need to do depends on which service it's waiting on. If it's the index service, then you probably need to design a more efficient index for the query. If it's the data service, then you should probably consider converting your query to a covered query. The last type of timing you'll find is the kern time. This is the amount of time the query service spent waiting for some CPU cycles. If this is high, it's a good sign that your query nodes might be overloaded. In other words, you probably need to add some more query nodes to your cluster. So it's at this point that you should have the problematic phase identified. And once you know where the problem lies, it should be a simple matter of looking at what is being done during that phase and to develop a more efficient way of accomplishing it. I hope this video has helped you understand how to break down a query plan to determine where you need to focus your query tuning effort. If you found it helpful, please hit the subscribe button below and ring the bell to be notified of additional videos in this series. And if you have a topic you'd like to see covered in this series, please let me know and I'll see if it makes sense to add to my list of topics to cover. And of course, if you need help in optimizing your Couchbase database, please reach out and give me a call. I'm here to help.